It all open to page 109. Can I use the shortcut here?
Yeah.
So it's x plus 2 x. Oh, what am I doing? X squared plus 2 minus 35, 2x. Can I do the shortcut here?
Yeah.
No.
Why not?
So I have to do FOIL because there's a 3. They have coefficients. What's that? This was your homework. This should already be done. What's that?
6x cubed.
6x cubed first. Outside. What's that? 9x squared. Inside. What kind of 10x? Minus 10x. And last. What's that? Negative 15. Are there any like terms? No, so it's done. I know. What's this one? 28x squared minus 7xy plus 8xy minus 2y squared. Why did I write this one like this, but this one like that?
Because he knew there were going to be different terms.
I found like terms, so I grouped them together in my work. And I got 28x squared plus xy minus 2y squared. What's this? Is it 9x squared plus 4?
No.
No. Why?
Because it's squaring the thing in there and there's an unknown variable.
Because that's the base. And squared means the whole base is squared.
You don't know because there's an incident.
9x squared plus 6x plus 6x plus 4. 9x squared plus 12x plus 4. What's weird about k?
I've got to simplify.
There's 3 of them. When I do these, I like to do those 2 first and leave that guy for the end, personally. That's the way I like to do these. You don't have to do them that way. But that's what I like to do. 4x squared minus 20x plus 25. And then, this is the same as FOIL, except it's not first, outside, inside, last. It's first, all the way through, and then second, all the way through.
Because you're getting the inside and the outside.
Yeah. So it's 8x cubed minus 40x squared plus 50x minus 20x squared, so I group it together, plus 100x minus 125. And then I add it all up to get 8x cubed minus 60x squared plus 150x minus 125. Yeah? Yeah. Same thing here. All the way through, all the way through. 2x cubed minus 4x squared y plus 3xy squared plus 2x squared y minus 3xy minus 4xy squared plus 3y cubed. Collect your like terms. 2x cubed minus 2x squared y minus 1xy squared plus 3y cubed. And finally, this mess. It's very hideous, yes? Because there's 4x, then a constant, then that is all one thing, isn't it? So, 2x squared, so we're going to do just that one first. What does that give me? 8x cubed y cubed. Then we're going to do that one. Minus what? 4x squared y cubed plus what? 2x. 3 minus 3? 2x. Absolutely correct. Done. Nice job. Put it on the internet. It's true forever.
Hey, we're gonna look this up.
Now we got to do 3 of these guys. What's the first one? What's the first one? 12, x7, y8. See how I messed up the order there? Didn't fool, who said that right? Didn't fool Marley. Minus what? Minus what? What's the next one? 28x to the 6th, y to the 6th, plus 32. X cubed, y 8th. Can everybody multiply polynomials?
Yes, pretty easy.
What if I gave you this? Could you multiply that?
Why don't you just combine all in terms?
There are no like terms to combine. You have to multiply first. Does anything change?
No, there's just one.
Where does that first y squared have to go?
To the other one.
To everything. Where does that second 3y have to go? To everything. Where does that third 9 have to go? To everything. And you would group your like terms. Doesn't matter. What if I had 4 and 4? Same thing. There'd be 4 lines. What if I had 2 and 4? There'd be 8 lines, because the first one would go to 4, and then the second one would go to 4. So there'd be 8 jumps. Does it matter? If you understand FOIL, xm plus xn plus ym plus yn. If you understand that, it doesn't matter how far I stretch the polynomials. Is everybody good?
Oh, because of the distributive property.
Because it's all distributive property. Really, the only thing you needed to know was this one, right? The original distributive property. As long as you know that that's xa plus xb, doesn't matter how far you stretch it. It's always going to work. Everybody cool? Yeah, all right. Let us move on. We are to quiz right now. Are you ready?
I thought it was another lesson.
I'm just asking. Are you ready? No, we won't quiz today. There's not enough people here. Let's go on to another lesson. Because this lesson's real easy and not incredibly important.
What does it mean, real numbers?
I'll get to what it means when it's time to get to it.
The numbers we learned before are real. There's a whole new number.
Okay. The real number system are the numbers we can define logically. All right? Now you guys, when I say the number system, when I say the number system, what do you guys think of? What images pop into your head? Decimals, what do you see? A number line. What do you see? 1, 2, 3, and so on. Excellent. So everybody can describe numbers to me, yes? Everybody is aware we have a system of numbers, yes? What is that system of numbers based upon? 10, exactly. What's the first number of that 10?
1.
No. No. 0. What is the last number of that 10? 9. Everything we do in 99% of our counting is 0 through 9. Does anybody want to guess why? Why?
Because we have 10 fingers.
We have 10 fingers. Excellent. All right. Now, there are cultures in the world that do not count the same way we do. For example, the Mayan and Inca cultures in Central and South America did not count to 10. They counted to 20. Does anyone want to guess why? They were running around barefoot. The number 20 in the Mayan and Incan calendar looks like this.
It's a double pitchfork.
Anyone want to guess why?
It's a person.
It's a person.
Yeah.
Everybody cool?
They also thought the world was going to end in 2000.
No, they thought the world was going to end at some point. We have applied our ideas of counting on them and guessed that it was supposed to be in 2012. But you can't do that because we don't actually know how they counted because there aren't any Mayans and Incas left.
Yeah, but they're not like...
All right, so is everybody cool? We all understand numbers, yes? All right, now, here's where it starts to get a little crazy. When I say the number system, and you think of all those things you said, you're all right. But math guys have a way of classifying that it helps to know. And let us do that. The first group of numbers of which we speak are the natural numbers. Now, what does the word natural mean?
They're basically produced without any GMOs.
Okay. Produced without GMOs. Who else has a definition of natural for me?
What's it called? Constants.
Constant? Okay. Joy. Yeah, all right. So, everybody, when I put my hand down, I want you to start counting. Okay? Just start counting. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
All right. Why did you start at 1?
Because
I'm getting to that. You started at 1. Somebody over here started at 1. I think back to kindergarten with Miss Schaefer, and Miss Schaefer said, let's count, kids. 1, 2. We always start counting at 1, right? How old's your baby? Do you ever say 0? You say 9 months until they turn 1, and then you can say they're 1. Nobody ever does. People still count by months till they're like 4. And how old's your baby? 37 months. So your baby's 3. 37 months. I'm 43, so I'm 480 plus 36. I'm 516 months old. Once your baby's 2, call it by years. Just personal pet peeve of mine.
Oh, yeah. What's the Adam Sandler movie where they have...
I don't know.
Went to the cabin?
See, how much do you know about me that you think I would know the name of an Adam Sandler movie?
I don't know, man. Like,
Although I think you're speaking of grown-ups.
yeah. They're like, how old is he? And they're like 48 months, and then they're like still breastfeeding him.
Yeah, that bothered me.
That bothered me too.
Not the breastfeeding part. I couldn't care less.
Yeah, I know. But
What bothers me is calling a 4-year-old 48 months old. Because when do you stop? Right? I'm 516 months old. I'm almost 528 months old because my birthday is in 19 days.
Oh, is it?
I'm 528 months old. In 9 days. All right. So, without me interfering, and if I hadn't talked about 0 to 9, what would your first number have been, Marley? 1. So the natural numbers are what I like to call the counting numbers. Back to kindergarten. 1, 2, 3, up to what?
10. No, but at
Infinity. Absolutely right. Now, is infinity a number or is it a concept?
It's a variable. Concept.
It is a concept because we will never ever get there because numbers are simply invented. Yes? We just give them names. They aren't real things. Everybody cool?
We could technically reach infinity if we counted from now to the end of the world.
No.
That infinity wouldn't exist.
No. Because then, if you go by that, then when the world ended, we end and time doesn't carry on. That's awfully selfish, don't you think? The universe goes on forever.
Until the sun explodes.
Well, that will deal with our 9 little planets in our little tiny corner of our single galaxy, of which there are an infinite amount of galaxies. So, everybody cool? All right. Now, next, we get the whole numbers. Now, when I say whole numbers, what do you think of? Numbers with no decimals. Absolutely, sure. Or no what? Fractions. Okay? So that's what you guys know of when I say...
You got a text.
Okay. I did get a text. That was my wife. That's not who I'm waiting for a text from. I'm waiting for a call from the orthodontist. But my wife just called because we tried to buy our flight to Ecuador last night on a credit card that we never ever use. Ever, ever, ever. And all of a sudden we wanted to put $3,000 on it. So the bank said, I don't think so. But now it's fixed. Now we can buy our flight. And we're going to Ecuador. You can all visit me. I have a spare room. But only until August 15th. So if you can get your poop together and fly to Ecuador before August 15th, you can stay for free.
I bet you'd be pretty mad if you showed up.
None of you are going to show up. None of your parents are going to let you fly to Ecuador by yourselves to stay with a guy you've never met. Your folks have met me. Your folks might allow it if I were to take you with me. I do not think they will let you fly to Quito and then figure out how to get all the way to Manta and then figure out how to get from Manta to San Clemente where I am.
Is Manta what they call Monterey's Monterey?
I don't know. But Manta is the capital of tuna fishing in the world. Ironically, according to my research, it is very difficult to buy canned tuna in Manta, the capital of tuna fishing.
Because canned tuna is all the byproduct.
Canned tuna is gross.
Yeah.
It's so good.
It's so gross.
It tastes like chicken.
Thank goodness that recorded. Okay. Ironically, there is a brand of tuna that is called Chicken of the Sea. Okay. Back to whole numbers. Whole numbers are indeed, yes, you know them as numbers with no decimals or fractions, but they have another definition, and that definition is this. The whole numbers are the natural numbers plus 0. So the whole numbers are 0, 1, 2, 3, up to infinity. Everybody good?
So it could be decimal then?
No. Everybody good? All right. Next, the integers. Now, you people understand, because for you people, it's quite obvious what is missing from these two lists. What is it? Negative numbers, right? Because negative numbers don't make a lot of sense, do they? They're an invention to explain subtraction, which is really just adding negative numbers. So the integers are the whole numbers plus the negatives.
Negatives are not whole numbers.
No, negatives are not whole numbers. All right? So, what does that mean? That means it goes from negative infinity, negative 1, 0, 1, 2, up to positive infinity. Is everybody cool? All right, now, make a line just above rational numbers and just below integers. In here, we are going to write everywhere above that line, there are no decimals. And if there's no decimals, that means what else?
There's no fractions.
Right. And no fractions. So you have to expand your definition specifically of whole numbers to include now only those things. Because whole numbers in the number system is different than whole numbers when we're talking about fractions and decimals. Everybody cool? Everybody good? All right. Now, being the intelligent people that you are, you're aware that between the numbers 0 and 1, there is value, isn't there? Right? Like, I have a pen, one pen. Now I have no pens. But if I was talking about money, I have no money. And now I have, what a letdown. Stop, don't, wait, just, you got a loonie in your pocket. Now I have a toonie. Is it possible to have a value between 0 and 2?
Yeah.
Yes. So we invented.
There's infinite value.
I'm getting to that, yes. This is why you guys get screwed up with math about grade 3 or 4 in Canada. Because up to grade 3 or 4, you are only dealing with whole numbers, aren't you? 0, 1, 2, 3, 4. Right? All of a sudden in grade 4, your teacher, who had a number line around the room, went up to the board and said, "Class." And you said, "Yes, Mrs. Badcrumble." And she said, started to explain fractions. And Mrs. Badcrumble, but you already knew fractions because that's how your parents disciplined you. We've done this joke, right? Go clean your room. No. 1. And then you ran and cleaned your room. And then you didn't go clean your room. Your mom said, "Go clean your room." No. 1, 2. And then you went and cleaned your room. And then your mom was like, "Oh man, they're figuring it out. I don't know what I'm going to do when I have to say 3. And then she would lie. And she would start the fractions. 2.5. 2.5 is. And that's when it started. Now, if your mom was really good at math, how long could she cut that 2.5 into? As long as she wanted. She could go 2.5, 2 3/4, 2 7/8, 2 15/16 for how long? Ever. And all of a sudden, 0 to 1 becomes infinite. And there is where math starts to get complicated for most of you. Let me pose this thought experiment to you. I am going to walk to the back of the room, but I am only allowed to cut half the distance every time. Will I ever get there?
No, if you jump.
Will I ever get to the wall? In theory. No, Because right now I'm 10 meters away, yes? Cut it in half. I'm 5 meters away. Then I'm 2.5 meters away. Then I'm 1.25 meters away. Then I'm 0.75 meters away. Then I'm 0.375 meters away. Then I'm 0.1625 meters away. And so on and so on and so on. Will I ever get there in number theory? No, because I can always cut a number in half. Will I ever get there in reality? Of course, eventually I will bash into the wall. But in number theory, I never get there. So that is why this is confuzzling for you guys. Well, not you, because you're the best and brightest, even if you believe everything on the internet is true.
I'm going to make a vlog about how to fix like chicken.
Okay?
I didn't say everything.
I know.
I just said some things like you putting in your poop.
So, rational numbers have two ways we recognize them. All right? One of them is this. This is definition 1. Any amount, because numbers just represent amounts, any amount we can represent as x over y. Anything we can write as a fraction, but there's some rules. X and y must be integers, and x and y cannot equal 0. If you ever see anything with a numerator and a denominator, and x and y can be represented as integers, you have a rational number. Is everybody cool? So, 2/3, rational. Because it's 2 over 3. They're integers, yes? What about 2 over 2/3? Is that rational?
No.
Yes. Because that is 2. Wake up. Wake up. Wake up. Yes. That is 2 divided by 2/3, which is 2 times 3/2, which is 6 over 2, which is 3, rational. Is everybody with me?
Is that the only definition?
No. I said there's 2 definitions of rational numbers. You guys you're smart young people. If we can use fractions, what's the other way we use to represent the space between whole numbers? Decimals. The other definition is this. Any decimal that ends or repeats. So, 2/3. If I put that into my calculator, I get 0.6666 for how long? Forever. It repeats. Everybody understand? If I put 1/8, is 1/8 the rational number? Is it integer over an integer? Yeah. Is the denominator 0? No. So I can do that on my calc. 1 divided by 8, and I get 0.125. It ends. So both of those are rational. Is everybody good with that? So now we've covered all the numbers we could possibly cover except irrational numbers. What must an irrational number be?
0.3 over 2, something like that.
It's anything that doesn't fit into the others. Everybody with me? So, what's the most famous irrational number that we have already used a lot this year? Pi.
The one time I put my hand in.
Pi. Because does pi ever end?
No.
Not that we know of. Does pi ever repeat?
No.
Not in the first trillion digits. Okay? There's a lot of irrational numbers. We use symbols for a lot of them. There's another one which is this, E. E is another irrational number. It's used in finance. It's like 2.21837 on forever and ever and ever and ever.
What is it?
Okay?
What's the calculation?
It's used for interest rates. It's also used in biology for like bacteria cultures growing and things like that. But there's others. The other irrational numbers are these guys, square roots. But not all of them. They're square roots when the answer isn't rational. So what's the square root of 4? 2. Is 2 rational? So the square root of 4 is rational. Everybody with me? What's the square root of 1/4? No.
Find out.
1/2. Because 1/2 times 1/2 is 1/4, right? Is that rational?
Yeah.
So that means the square root of 1/4 is rational. Is everybody cool with that? What's the square root of 3? Do it on your calculator. What do you get? No, you won't get an error. You'll get 1.732, and your whole screen fills up, yes? Keep reading me numbers till your screen ends, Damaris.
05080.
Okay. Now, because your whole screen filled up, 99 times out of 100, if your whole screen fills up on your calculator, there's the orthodontist. Excuse me. Hello. Speaking. Hi, how's it going? Uh-huh. Please do. Thank you. Okay. Bye-bye. Damn it!
Did they put you on hold?
They can't change my kid's appointment.
Does that mean that you're losing out on something?
Yes. I will have to move it to another day. Or, I don't know. I haven't decided. Anyway, it is irrational. Okay? Any time that your screen fills up in a giant muckety-muck mess, you can assume that it is irrational. Is everybody cool? And that covers all the numbers that we use. The only thing left is something that I'm just going to mention to you because you won't see it until second year university. And that is the square root of negative numbers. They don't make any sense, do they?
Let's try it.
You can't.
How come it doesn't?
Because what does square root mean?
Error.
What does square root mean?
Times itself.
Something times itself, yes?
It's always positive.
So it has to be positive. Because two negatives, -2 times -2 is +4. So -4 cannot have a square root. But math guys, especially in things like electricity and stuff, they need to have square roots of negatives to make their equations work. So this is why this page is called the real number system. The square root of negative numbers are the imaginary numbers. And I'm not joking. They exist, kinda, in a theoretical sense. We need to be able to do this. You guys will not have to be able to do this until second year calculus or second year physics at university, but I do not want you to say, I have never seen that before.
No, I'm still gonna say it so you.
Of course you are. So he can say, who teaches high school? And then your prof can get all mad. Right? Everybody cool? All right. Turn the page over. Do A. Convert 1A to a fraction. First try. Would you leave it as 12 over 100?
No, I
Why?
reduce it because you can reduce it.
Reducing is the wrong word. Because reducing means you make something smaller. Simplify it. To what?
6 over 50, and then I can do it again. So
To what?
3 over 25, which is the smallest we can get.
Excellent. Can I go the other way and have the answer still be right?
Yeah.
Is 24 over 200 still 0.12?
Yeah.
Yes. Is 36 over 300 still 0.12? Yes.
0.12 over 1 still 0.12.
Yes. Everybody cool? All right. Now, what does that little line mean?
He's repeating.
0.11111 for how long?
Ever.
Ever. What's that as a fraction? Some of you already know the shortcut here. If you know right now what that is as a fraction, do not say it.
Okay.
Everybody else? What is a guess? Okay, what is it, Luke?
Over 9.
It's 1/9. Why?
I forget.
Did everybody know it was 1/9? Good. Let's talk about why. What, Marley, is 0.1 as a fraction?
Whoa.
Over 100?
1 over
1/10. Agreed? Right? Okay. 0.1111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111111If it repeats, it therefore must be rational, correct? So if it's rational, we must be able to write it as x over y, correct? Okay. We know that the 1 has to be the numerator, right? Now we have to think. The y has to be an integer, yes? Right? To make it a fraction, to make it a rational fraction, that has to be an integer. Yeah? Is 0.111111111 bigger or smaller than 0.1? Very, very slightly bigger, isn't it? 11 cents is bigger than 10 cents, yes? Okay. So I must need the integer that I can put here for y that is the next integer that is bigger than 10 in fractions. So why is it 9? 9 is smaller than 10.
But a 9.
But a 9th is bigger than a 10th. Does everybody understand? That's why that is 1/9. Now, being the smart individuals that you are, what would 2 be? If 1 was 1/9, what would what would that be? No. 2 over 9. Right? Because 0.2 would be 2/10. This is slightly bigger than 2/10, and the denominator has to be slightly bigger than 10, but still be an integer. Everybody good? All right. Now, look at D. Where is the bar? It's only over the 4. So it's 0.5444444 forever. Well, if it was 0.54, then what would it be? 54 over 90. 99. Because this is 154 over 100, isn't it? Okay. So if it was 54 over 100, it'd be 54 over 99. But it's not that, is it? There's another trick.
I don't know.
What do you think it is?
I think it's just a trick. It's just the math people are laughing at us and they're like,
What do you think it is? Excellent. There's your homework.
That question is our homework.
That's part of it. Homework is
Make a guess.
make that, and explain. Now, listen to me. When I say explain, do I mean tell me how to do it?
No.
Or do I mean tell me why? Or do I mean both? Let's see what happens when I send you away with that. Now, next, this page 111, put them in the appropriate categories. Now remember, the categories are natural, whole, integer, rational, irrational. Now,
And imaginary.
oh yes, and then imaginary, which is capital I. Now, look, if something is natural, does that automatically make it a whole?
Yes.
If something's a whole, does that automatically make it an integer?
Yeah. 'Cause if it's
Really?
category two.
Yes. So, it goes like this. Does it go the other way?
No.
No. Can you be rational but not an integer?
Yeah.
Yeah, 1/2. Right?
Big.
Everybody cool? It's like those Russian nesting dolls. You know the things I mean?
Yeah.
Everybody knows what I mean? Yeah. There's the big one. The big one would be rational numbers. Open it up. Oh, look. There's my integers. Open it up. Oh, look. There's my wholes. Open it up. Oh, look. There's my naturals. Okay? So go. See what you can do up to page 111. And then your homework is page 112 plus that question. Okay? Tomorrow you have a quiz on multiplying radicals. Multiplying polynomials. And exponents.
What is with A?
Go. I got to go to the washroom.
Do this cube. Do the cube.
So, what's that first one?
Irrational.
It's irrational. Why is it not imaginary?
Comes out as a negative decimal.
If it's a square root, you can't do it, right? Because -2 times -2 is a positive number, right? But what is -3 cubed?
It's
-3 times -3 times -3 is -27, yes? So can you have cubed roots of negative numbers? Yeah. Let me ask you this. What if I said it was the fourth root of -14? What's that?
That can happen. Why not?
That is imaginary. Why? Because I need 4 instead of 2. Still an even number. I'm going to end up positive again. Everybody cool? All right, what's this guy? Is that guy rational?
He's a natural.
Yeah, he is a natural. Thank you for jumping all the way to the end. Why is he natural?
Because 25 squared is 25 equals 5.
5. And 5's a natural.
There's no reason to say it's a whole number unless it's 0.
Mm-hmm. What about that guy? I'm being gender specific. What about that number?
It's irrational.
Is it?
No, it's not. It's rational. I put
It is rational. Why is it rational?
because it stops.
Because it ends. It terminates. It ends at the 4. Because that is really 5 and 319 754 millionths. Isn't it? Right? Okay. What about the next one?
What's the next one?
D.
Oh,
I didn't put anything for it. I forgot what it is. I think that it's
It is natural. Why?
Because.
That's what your quiz is on tomorrow. Everyone should know this.
What the heck? I don't know. Oh yeah, because it's it equals a positive number.
Right. Negative 2 4 times. Negative times a negative is positive. Times a negative is negative. Times a negative is positive. So it ends up being positive 16, which is natural. What about 9?
Natural.
Natural. What about the square root of negative 4? Imaginary.
Oh, you're actually doing imaginary? Actually, you're right.
It's not. It's imaginary because it doesn't exist. And what about this one?
Yeah.
Look closely. Green says it's rational. Why?
I say it's irrational too.
Because 1, 8, 1, 8, 1, 8 repeats, right? Now wait, is there a bar over it anywhere?
No. There's the dots though.
The dots means this carries on. But does it guarantee?
No.
Could not the 10 millionth decimal be a 7?
That's what I thought, but.
So,
But we didn't. You would never.
exactly. This one, we have to say it appears rational, but it might be irrational because there's no bar. What if I did this and took away the 3 dots? That's rational. For sure, because the 181818 repeats. Do you understand the difference?
Oh, because the numbers are supposed to be distinct.
Yeah. Does everybody understand the difference? Okay. The key here is that word for what we had here. Cool?
Yeah.
All right. Like I said, you have light work tonight because I knew a bunch of people weren't going to be here. So, you're going to just do 112. The answers are right there. It will take no amount of time. And you're going to go home and you're going to try to figure out that for me. Right? Quiz tomorrow, practice tests tomorrow. Wednesday, regular lesson. Thursday, where are you for X block? Here, writing that contest. What?
I'm in Victoria for rugby.
So you can't be here writing that contest. That's why I'm doing it in the next block.
No, we beat that morning.
I know. That's why I'm doing it in X block. Okay? So it doesn't use up a class. All right, everybody good? Yo, yo.